In this video, we're going to talk about solving equations with rational exponents, which is just a fancy way of saying we're going to be solving equations that have fractional exponents with x. Before we get started, I wanted to do a quick review with you of just factoring so that we can kind of go in depth of what exactly that we're doing so that we can apply that to using it with fractional exponents. So if I give you the example, 3x squared minus 4x cubed plus 2x to the 7th, and I ask you to factor that. Normally what we do is we like to write things in descending order, meaning we write it from the largest to the lowest exponent. So I'm going to rewrite it as 2x to the 7th minus 4x to the 3rd plus 3x squared. Okay, once we do that, we look to see what they all have in common. And a lot of times when we're looking at the variable, it's whatever the lowest power would be. So if we look, the lowest power is x squared, and they all have an x squared in common. So I'm going to pull out the x squared. And what's left would be 2x to the 5th minus 4x plus 3. Now that seems pretty natural to us and intuitive because we've been doing it for so long. But really what we're doing, if you look, once we find out whatever they all have in common, what we're doing is we're taking each term and dividing by whatever they have in common to figure out what's left over. So if you look at 2x to the 7th, if I divide that by x squared, that's going to give me a 2x to the 5th. So that's how we know what goes in here. Then we figure out what goes in here because we take the 4x to the 3rd and we divide by x squared. Right? So that would give me 4x. And if you remember too, if we look back even further, remember when we divide and we have bases that are the same, we subtract our exponents. So if we look at this one, we have x to the 7th over x squared, and that's where x to the 5th comes from. X to the 3rd over x squared, that's where this x comes from. So what we're doing is we're taking whatever they have in common and we're dividing each term by that to figure out what goes on the inside, what's left over. So that's what we're going to do. Even though it seems a little bit weird to do it with fractional exponents, it's still the same procedure. So if we look at this next example here, solving equations with rational exponents, we're looking at example 1. The first thing we want to do is we put it in descending order. So we have the largest exponent down to the smallest exponent. And this one's already set up for us. We have 3/2, which is the biggest exponent, and then 1/2, which is the next biggest, and then -1/2, which is the smallest. So it's already set up in order for us. The next thing is we want to look at the what they all have in common. And since this is the smallest exponent with x, they all have x to the -1/2 in common. So I'm going to pull out an x to the -1/2. Now, just like we did in the previous review example, to figure out what goes on the inside, we're really just dividing, which in turn is really just subtracting my exponents. So to figure out what goes in the first spot, I'm going to take x to the 3/2 and divide by x to the -1/2. If I have x to the 3/2 and I'm dividing by x to the -1/2, I have to subtract my exponent. So I have 3/2 minus a -1/2. So that's a double negative, which means I have 3/2 plus a half, which would give me 4/2, which is 2. So this gives me x squared on the inside. Okay, now the next one. So I have -10x to the 1/2, and I'm dividing by x to the -1/2. So I got to figure out what my exponent would be for x. So I have 1/2, and I'm subtracting a -1/2, which means it's going to be a double negative. So I have 1/2 plus a half, which is 1. So what goes inside here is 10x to the first. The next step, or the next term, I have 25x to the minus 1/2, and I'm dividing by x to the minus 1/2. So these are the same, so they just disappear, and I'm left with 25. So that is what goes in my third spot here when I pull out the x to the minus 1/2. Okay, next step is I'm going to keep factoring. I can factor x minus 10x plus 25 as x minus 5, x minus 5. Now I can set each factor equal to 0. Since x minus 5 is there twice, I only have to write down one equation, x minus 5. This has a solution of 5. This has no solution because, remember, negative exponents means we take the reciprocal. And if I take 1 over 0 to create the reciprocal, I'm dividing by 0. And we can't have that. So this yields no solution. So my only solution here would be x equals 5. Okay, next example was fractional exponents. Again, we want to make sure it's ordered from largest exponent to smallest exponent. And in this case it is. I have my largest exponent, which is a half, down to negative a half, and then down to minus 3/2. So now I look to see what my smallest exponent would be. It's this one right here, x to the negative 3/2. So that's what I'm going to pull out. That's what they all have in common. And now I got to figure out what goes inside by dividing. So if I take x to the positive 1/2 and divide by x to the negative 3/2, I'm going to subtract my exponent. So I have 1/2 minus a negative 3/2, which would be 1/2 plus 3/2, which would be x to the 4/2, which is x squared. The next one, we have minus x to the minus 1/2 over x to the minus 3/2. So to figure out what my exponent would be, I take minus a half and I subtract a negative 3/2. Since it's a double negative, I would have minus a half plus 3/2, which would give me a 2/2, which is 1. So in here, I'm going to have a minus x. Okay, and then when I take a minus 3/2 out of the negative 6x to the minus 3/2, I'm left with just minus 6. So now I'm going to keep trying to factor it. Since this is a quadratic, I can keep going. So I have x to the minus 3/2, and I can factor this as x minus 3, x plus 2. So if I set each factor now to 0, this yields no solution because this is a negative fractional exponent, and when I flip the 0 to get rid of that negative exponent, that ends up dividing by 0, and we can't do that. But this one here gives me a solution of 3, and this one here gives me a solution of 2. If you recall, when you have something raised to the 1/2 or to the 3/2, that 2 in the denominator of your fractional exponent represents the square root. And remember, you can't take square roots of negative numbers and still be a real number. So if I go back to plug in this answer into my original, I'm going to get negative 2 raised to the 1/2 minus negative 2 to the minus 1/2, etc. I can stop right there because if you look, this is telling me that I'm taking the square root of negative 2. And I can't do that. If you plug that into your calculator, you're going to get an error message. So we're also going to cross off this answer as well. And we're going to say that our only solution to this is x equals 3. So to sum up, when you see an equation that you need to solve and it has fractional exponents, the first thing you want to do is put it in descending order. Then you want to factor out what they have in common. And then if you need to continue to factor, keep in mind if they're fractional exponents, it's an even number in the denominator. That means it's an even root. So when you plug back into check, negative numbers aren't going to work. If you have a factor that's set equal to 0 with a negative exponent, you can't flip that without dividing by 0, which is a big no-no and the world blows up when you divide by 0. So some things to keep in mind and a quick summary of what we covered.